Welcome back to the deep dive. When we talk about cybersecurity today, it's so easy to frame it as this ongoing arms race.
Right. Attackers build something new, defenders build a higher wall, and so on.
Exactly. But looking ahead to 2026, that whole analogy, it completely breaks down. What we're really seeing isn't an arms race. It feels more like a contest of speed, of adaptability, where AI is just blurring the line between a human attack and a machine-run operation.
And that's the core shift we really have to get our heads around. Our mission today is to do a deep dive into the latest security predictions. We're going to look at this AIification, the industrialization of threats across everything from your cloud perimeter all the way into your internal systems.
I want to push on that word you used, industrialization, because when people hear automation, they just think of a script running on a loop. How is industrialization different?
Oh, it's a massive distinction. Simple automation is just repetitive. Industrialization is adaptive, it's scaled, it's distributed. The core thesis for 2026 is that AI hasn't just, augmented threats. It has fundamentally industrialized cybercrime. And that means the barrier to entry for really sophisticated attacks has just collapsed.
So that you don't need to be a coding genius anymore.
Not at all. I mean, 5 years ago, if you wanted to launch a zero-day or a complex intrusion, you needed deep, deep technical expertise. Today, you just need to know how to use the right AI tools.
Wow.
These tools automate everything, the recon, creating the payload, the whole exploitation process. Attackers are hitting a speed and a scale that used to be only for the most elite state-sponsored groups.
And that acceleration, that is the central threat. It's not just scary from a defense perspective, it's terrifying when you see how fast organizations are moving to innovate. This pace, especially in development, what some people are calling vibe coding, it demands that security has to be proactive. It has to be woven right into the process. And before we unpack all that, we have to thank our sponsor, vibehack.dev. Their whole focus is on building the tools to tackle this exact machine speed problem. They've got a full stack of DIY micro tools for the entire DevSecOps lifecycle.
Which is so critical right now.
It is. So whether you're securing your internal EP integrations, your container deployments, or the whole DevSecOps pipeline, vibehack.dev is delivering those focused solutions you need for this speed challenge.
In that speed, it's most obvious when we look at the rise of autonomous agentic AI.
Okay, let's break that down. Agentic AI. Sounds a little like science fiction. How is that different from the AI we've been using for the last few years?
Well, traditional AI is mostly reactive, right? It looks at data, gives you a recommendation. Agentic AI is proactive, it's operational.
So it does things.
It does things. These systems can reason, they can plan, and they can act across multiple steps.
Yeah.
All without a human constantly telling them what to do. They don't just answer a prompt and stop. They kick off entire workflows, adjust their own plans, and interact with real systems.
So, okay, let's say I'm running a factory. I have AI agents managing my supply chain of production. What happens if one of those agents gets compromised?
That's the critical threat right there. A compromised agent instantly becomes an operational attack vector because these agents have privileged access to everything.
ERP systems, network control.
Exactly. So a single breach lets an attacker pivot laterally and just cause chaos. We're talking about agentic edge AI. So in a smart factory or in autonomous cars, a compromised agent can literally control physical devices. The threat is no longer just about data.
It's physical disruption.
It's physical.
It feels like we're handing over decision-making power that we used to reserve for trusted people. But it gets even crazier. Because it's not just about malicious agents. We also have to worry about agents that are just wrong. This gets into that automated to automated, or A2A, workflow concept.
Yes, this is a huge emerging threat model. In a normal system, a human looks at the output before the next step happens.
Right, a sanity check.
A sanity check. But in A2A environments, agents are designed to trust each other's outputs to move at machine speed. So if one agent, say, a data analysis agent, has a hallucination, it generates an error that looks plausible.
It just passes that bad data right down the line.
It passes that unchecked data to the next agent, the operational one.
Can you give us a real-world example of how that could cause damage?
Sure, let's stick with logistics. You have a demand forecasting agent. Maybe because of bad training data, it hallucinates a sudden, massive spike in demand for one of your products. a 500% increase.
Okay.
It passes that data, which looks totally valid, to the ordering agent. The ordering agent, which is programmed to trust the forecast, doesn't start for a human review. It immediately places a huge, unnecessary, and really costly stock purchase.
And the damage is done before a human even sees an expense report.
Mhm.
So the defense problem isn't about looking for malware anymore. It's about monitoring systems that verify their actions after they've already spent the money.
Exactly. Your legacy security tools are completely blind to this. You need agentic AI on the defense side, too, something that can triage and contain these things at machine speed, because waiting for a human means the damage is already done.
The defense has to be as autonomous as the attack.
It has to be.
Which brings us perfectly to the development pipeline, where all this speed starts. We mentioned vibe coding a minute ago, this rapid AI-assisted code generation. It's making developers so much more productive, but it sounds like a huge double-edged sword for security.
It's efficiency at the cost of security, if you're not careful. Vibe coding is, using LLMs inside your IDE to finish your code, suggest logic, build whole apps in a fraction of the time. The speed is amazing.
Yeah.
But one big study found that when developers use these tools, the code they generate is insecure and exploitable 45% of the time.
45%. That's not a small number. That's almost half. If companies are rushing that AI-generated code into production without a solid review.
They're just injecting new vulnerabilities at machine scale. And this creates some really unique supply chain risks, ones that are engineered specifically to exploit how AI works. One of the scariest is something called slop squatting.
Slop squatting. Okay, that's a great name. Break that down for me.
It's a new level of patient, malicious planning. It exploits the fact that LLMs hallucinate.
Right.
So a developer is vibe coding, and the LLM suggests a library or a package that sounds right, but it doesn't actually exist. It just made up the name. Threat actors are watching for these common hallucinations, and they quickly go and register those fake library names on public repos like NPM or PyPI.
Oh, wow. So they're setting a trap.
The trap is set. Then, later on, another developer, or worse, another AI agent, uses that same hallucinated name, and boom, the attacker's malicious, slop-squatted library gets pulled right into the company's software supply chain. The attack weaponizes the AI's own mistakes.
That is deeply unsettling. The attacker doesn't even have to hack you. They just have to predict what your AI is going to get wrong.
Precisely. And it's even worse when you add in the threat of malicious models themselves. We're seeing tampered GGOF models being uploaded to places like Hugging Face.
Can you just quickly define a GGOF model for us?
Of course. GGOF is basically just a really optimized file format for an LLM. It lets you run it efficiently on your own local hardware. They're designed to be easy to deploy, which is great. But
if it's tampered with.
If it's tampered with and you deploy it for inference to actually run the model, it can execute a backdoor or malware right inside your environment. It's why you have to have strict policies about only using pre-approved AI models outside of a sandbox.
So AI is speeding up the creation of bad code and the delivery of supply chain attacks, which brings us to 0 days. If AI is so good at writing code, can it also find security flaws faster?
Oh, it accelerates both discovery and exploitation. Dramatically. AI-driven systems are getting very, very good at finding vulnerabilities, not just in some companies' software, but across massive open-source code bases.
But wait, if attackers are using AI to find flaws, aren't defenders using it too? Doesn't that sort of level the playing field? Why does the attacker still have the advantage?
That's a great question. The attacker has the advantage because of the asymmetry of defense. An attacker only needs to find one single way in. Just one. The defender has to secure everything.
All the time.
All the time. AI makes finding that one successful entry point and automating the exploit so much faster for the bad guys. It just widens the gap between when a patch is released and when it gets exploited everywhere.
And protecting the code, the whole pipeline, against these AI-driven threats, the unsecure vibe code, the slop squatting, it really requires tools that are built right into that workflow.
You need that visibility.
You do.
Yeah.
Which is a good moment to again thank our sponsor, vibehack.dev. If your team is struggling with this speed, their DIY micro tools for the DevSecOps and container lifecycle give you that precise control you need to fight these new supply chain risks.
And if we move from the development side to operations, we see AI is industrializing the big enterprise attacks too, especially ransomware and APTs.
Ransomware just keeps evolving, doesn't it? It sounds like we're way past the days of just encrypting files.
Completely past it. Ransomware is now a fully automated, AI-driven operation. It scans the network, finds a vulnerability, and runs the extortion phase with almost no human input. But the biggest change is the extortion itself. It's not just encryption anymore. It's intelligent data exploitation.
What do you mean by that?
The AI now analyzes all the stolen data. It doesn't just read text files. It's scanning images, voice recordings, videos, everything to find the victim's most sensitive assets for targeted pressure.
So it's looking for leverage.
Maximum leverage. If you're a hospital, the AI finds the patient data. If you're a law firm, it finds the board meeting recordings. It immediately identifies whatever will create the most psychological and legal pressure.
And that kind of intelligent extortion is so much more damaging than just locking files. And now this capability, this advanced tool, is being democratized.
Yes, that's the industrialization part. The rise of AI-powered ransomware as a service, RAS, means even low-skill criminals can launch these incredibly complex adaptive campaigns. The tech is just packaged up and sold.
So what about the state-sponsored actors, the APTs? They're also adopting new models, I hear. Tell us about this Premier Pass as a service.
So this is all about high-coordination alliances to maximize efficiency and hide their tracks. One group, a highly specialized APT that's great at breaching defenses, gets the initial access, the foothold.
Okay.
They then pass or sell that verified access to a second, totally separate group whose specialty is espionage or data exfiltration.
So it's like operational outsourcing for hacking.
Exactly. The first group gets paid for the access, the second group pulls off the mission, and the handoff makes attribution a nightmare for defenders. The forensics point to two completely different actors with different goals.
And at the same time, they're using AI to perfect the classic insider threat. This is the synthetic insider threat.
A huge concern. Nation-states are getting better at physically embedding operatives inside organizations, posing as employees. They're using forged identities, deepfake-assisted video interviews, and entire AI-generated personas to get past background checks.
So they look like the perfect hire.
The perfect hire. They interview flawlessly, their resume is perfect, because an AI optimized the whole persona to bypass corporate screening, and once they're in, they have privileged access for long-term espionage.
And on that topic of identity, AI is just supercharging social engineering. For years, we've told people, look for the typo in the phishing email. That advice is basically useless now.
It's completely obsolete. Generative AI creates personalized, context-aware messages that are indistinguishable from something a human wrote. The AI is trained on your public data, your company's org chart, your communication style.
So it knows who to impersonate and how.
It knows exactly how to sound like your boss asking for an urgent wire transfer. The classic clues, the typos, the weird tone, they're just gone.
And it's moving beyond just text into voice and chat.
Yes, these semi-autonomous fraud bots are a real threat. They can impersonate customer service or a bank employee and engage with thousands of victims at the same time. The AI manages the conversation, making these scams incredibly efficient.
Let's pivot to the cloud. It's still a massive target, not because the platforms are insecure, but because organizations keep making the same mistakes.
Precisely. The cloud is a prime target because attackers are still exploiting the basics. Misconfigurations, overprivileged credentials, exposed APIs, insecure containers. The sheer complexity of managing it all creates the gaps.
And that complexity just explodes when you're using multi-cloud.
It creates a huge visibility problem. Our data shows almost half, 47% of organizations struggle to maintain full visibility across all their multi-cloud assets.
47%. That's a massive blind spot for an attacker to move
A
through.
huge blind spot. If you can't see it, you can't secure it.
And now there's a new high-value asset in the cloud, the GPU resources themselves. Why are cloud GPUs a target?
They're extremely valuable. Attackers target them for compute theft, to run crypto miners or malicious AI models, or to resell the access. But the bigger concern is that it challenges the basic promise of cloud isolation.
How so?
We've seen microarchitectural flaws, like one called NV Bleed, that show data can leak between tenants on the same GPU. Now, these are still very sophisticated attacks, but they have to change how you think about risk for sensitive data in a multi-tenant GPU environment.
So we've covered a lot: agentic AI failures, industrialized ransomware, broken developer pipelines, cloud blind spots. What's the ultimate takeaway for an organization trying to stay resilient into 2026?
The key takeaway is that the biggest danger isn't always some new zero-day exploit. It's the invisible misuse of trusted tech. The hallucinating AI, the compromised agent, the insecure vibe code. Security has to move from being reactive to being anticipatory. It has to be embedded everywhere.
So for everyone listening, what are they say 3 concrete things they need to be doing right now to fight these machine speed threats?
First, lock down the code supply chain. Every piece of AI-generated code needs automatic security evaluation, and any unapproved AI models have to be kept in a sandbox, period.
Makes sense. What's number two?
Second, you have to secure your new workforce,
Yeah.
the AI agents. You need enhanced identity and access management IAM with continuous authentication. Traditional IAM was built for humans logging in, not for machines accessing things 24/7. It needs an upgrade.
And finally, with all this risk, you can't fix everything. So prioritization.
Absolutely. You have to move away from just patching based on a severity score. Organizations need to adopt cyber risk and exposure management, or CREM.
Can you elaborate on what CREM is?
So CREM is a smarter way to prioritize. Instead of just a list of vulnerabilities, it gives you a data-driven view of business risk. It looks at three things at once: how critical the asset is, how exposed it is, and how likely it is to actually be exploited.
So you fix what matters most to the business, not just what has the scariest score.
Exactly.
Securing that full development pipeline is really the core defense here. So thank you one last time to our sponsor, vibehack.dev, for offering that comprehensive suite of DIY micro tools across the full DevSecOps lifecycle.
And as we wrap up, let's look even further out, beyond 2026. There's a long-term risk we need to act on today: quantum computing.
Right, the whole harvest now, decrypt later threat.
Correct. The big worry is that sophisticated actors, mostly nation-states, are stealing huge amounts of encrypted data today. They can't break the encryption now, but they're storing it, waiting for quantum computers to mature.
So what does that mean for a security team today?
It means you have to start migrating your most critical, long lifespan data to post-quantum cryptography now. NIST estimates that current standards might be deprecated around 2030. If you have data that needs to stay secret for 15 years, the time to prepare for the quantum threat isn't in 5 years. It's right now. The harvest is already happening.